Now we are going to discuss about the definition of the covariance. Covariance means we are discussing about the relation in between of the two variables. Those are from the given data, that is the relation of any two variables. The covariance of the two variables can be defined as expectation of the difference of the variables and its means product. That is, let capital X and capital Y be the two random variables with means X bar and Y bar respectively. Then the covariance between the two variables X and Y is defined by the relation covariance of X comma Y is equal to expectation of product of their respective difference of the mean and variable, that is X minus X bar minus into Y minus Y bar expectation. And after this covariance of X and Y as equal to expectation of XY minus expectation of X bar into expectation of Y bar, that is X bar and Y bar are the constants here, expectation of X into expectation of Y. Here just we can take the multiplication, that is X minus X bar into Y minus Y bar is equal to XY minus XY bar minus X bar Y minus X bar Y bar. That is expectation applies on both sides, then expectation of XY minus expectation of XY bar minus expectation of X bar Y minus expectation of X bar Y bar. It is equal to expectation of X minus X bar into Y minus Y bar. Here, after the simplification, expectation of xy is xy only. Here, y bar is a constant. So, this expectation of x bar is minus y bar, x bar will come. Why? Because y bar is a constant and e of x bar x equal to e of x. So, here we can write it as, in the place of e of x is x bar minus x bar is a constant right outside, e of y means y bar, and this is a constant, we are getting the x bar and y bar. Okay, here minus into minus plus will come here, so plus these two are get cancelled, we are getting the expectation of xy minus expectation of y into expectation of x. So whatever the multiplication is there, we can apply in that, and we know that the expectation of x is x bar, expectation of y is y bar, then both will get cancelled. Why? Because x bar y bar is a constant, we are getting the same expected value is a constant. After the simplification, we are getting the expectation of xy minus expectation of x into expectation of y is equal to covariance of x comma y. Simply we can take the product of their corresponding differences of the variables expectation is equal to covariance of the x comma y. Next, in this sum, Note points are there, important note points. Note 1. Covariance of x plus a comma y plus b is equal to covariance of x comma y only. The second one is covariance of ax comma by is equal to ab covariance of x comma y. And third one, note 3, if x and y are two independent random variables, two independent random variables, then covariance of x comma y should be 0. These three are very important points we have to remember. And definition. And that definition can be defined in another way. What is that? Suppose if we can take x1 comma y1 and x2 comma y2, so on, xn comma yn be n pairs of observations on two variables capital X comma capital Y, then the covariance of x and y written as covariance of x comma y is defined by covariance of x comma y is equal to 1 by n summation I equal to 1 to n xi minus x bar yi minus y bar. Let it be equation 1. Here x bar and y bar are the x bar is a mean of x and y bar is mean of capital Y respectively. In this, covariance is an absolute measurement. The covariance of the x and y, that is covariance of x comma y, is measured of joint variables in x and y. Just like 1 by n summation 1 by n summation I equal to 1 to n xi minus x bar whole square is the variance of x. It is the variance of x. In the same way, 1 by n summation I equal to 1 to n yi minus y bar whole square is the variance of y. Similarly, 1 by n summation I equal to 1 to n xi minus x bar into yi minus y bar is the covariance of x and y. Here it is individual variance means we are taking the square. It is individual variance means we are taking the square. But here we are taking the relation of the variance in between of the x and y means the square becomes product of their respective mean and its each and every observation difference. Okay, that is nothing but the idea of the variance in a single variable x or y Variance gives an idea of the giant variance in the both variables taken together. That is the thing. Here, individuals here taking together, the same relation is there. And here, the covariance of this, in this covariance of x comma y is equal to 1 by n summation I equal to 1 to n of xi minus x bar into yi minus y bar. After the simplification, 1 by n summation I equal to 1 to n xi yi minus xi y bar minus x bar yi minus into minus plus x bar y bar. After the simplification, these two are get cancelled. We are getting the 1 by n summation I equal to 1 to n xi yi minus x bar into y bar. Since summation I equal to 1 to n xi is x bar and summation I equal to 1 to n yi equal to y bar. So here y bar will come, here x bar will come. These two are get cancelled. We are getting only one x bar into y bar. This is the one more type we can use any formula. We can take the expectation of x minus x bar into y minus y bar is the one formula, and covariance of the x comma y is 1 by n summation I equal to 1 to n xi yi minus x bar y bar is the another formula. In this we can discuss the curl pairs and coefficient of correlation. These are the covariances. Here covariance formulas are two types are there. One is covariance of x comma y is equal to expectation of xy minus expectation of x into expectation of y, or it can be taking as expectation of x minus x bar into y minus y bar. This is the another formula, and we can taking as covariance of x comma y variables equal to 1 by n into summation I equal to 1 to n xi yi minus x bar y bar. We can use any one of the formula, and if they are asking the covariance, then we can find out. And this covariance is the relating in the correlation. Okay. Next definition is the coefficient of the correlation, and we can find out the coefficient of the correlation by the Curl-Pearson's method. Okay, here correlation is a statistical technique. This is the correlation is a statistical technique. Okay, this statistical technique used for analyzing the behavior of the two variables, to analyze the behavior of two variables x and y. Suppose here the covariance of x and y means we can define. Now we can discuss about the coefficient of the correlation means it is a statistical technique. It is used for the analyzing the behavior of the two or more variables. In this analysis, we discuss the association between two or more variables. The statistical measures of correlation, this correlation is relates to covariance between series but not of function or causal relationship. This correlation is relates with covariance between series but not of functions. Or causal relationship. Here, series means we can take covariance of x comma y is equal to 1 by n summation I equal to 1 to n xi yi minus x bar y bar. that is the series relation. So here we are discussing, or we can say that correlation is a related to covariance between the series but not of the function. Okay, now we are going to discuss about the method of the Curl Pearson's coefficient correlation. Curl Pearson's coefficient correlation. In the method of the Curl Pearson's, how to find out the coefficient of the correlation means, in this we can take the small r denoted by the correlation is denoted by the small r, and it can be defined by the method. This method is widely we are using, and it is also called as product movement correlation coefficient. Here correlation is denoted by small r, and this Curl Pearson's method, this method is known as is also called as product movement correlation coefficient. Correlation coefficient. The Curl Pearson's coefficient of correlation or correlation coefficient small r between the variables x and y, it's defined by the formula. What is that? Curl Pearson's coefficient of correlation, or simply correlation coefficient small r between the variables capital X and capital Y be defined, or it is defined by the formula small r equal to covariance of X and Y divides standard deviation of X into standard deviation of Y. This is the formula of the coefficient correlation. It can be taking as that is nothing but small r is equal to covariance of x comma y by sigma x into sigma y, or it is equal to summation xi minus x bar into yi minus y bar by n into sigma x sigma y. Here sigma x is the standard deviation of x, sigma y is the standard deviation of y. And here sigma x is equal to under root of 1 by n, sigma I equal to 1 to n xi minus x bar whole square, and sigma y is equal to under root of 1 by n summation I equal to 1 to n xi yi minus y bar whole square. This is the, and it can be written as, if we can take the xi minus x bar is equal to capital X, and yi minus y bar equal to capital Y. Substitute in above. So here we can write it as the R covariance of correlation of x and y is small r is equal to summation x y by under root of summation x square into summation y square. Here we can substitute xi minus x bar equal to capital X, yi minus y bar equal to capital Y. Since we can write it as summation xi minus x bar into yi minus y bar is equal to xy, and here n is there, here 1 by n, 1 by n, under root means under root. After the simplification, it is sigma x, means we can write it as sigma x equal to under root of summation x square. Why? Because this 1 by n comes in here only, and under root of summation y square is the sigma x and sigma y. Why? Because we know that dx equal to xi minus x bar whole square, so we can write it as under root of. So this is the correlation coefficient or coefficient of the correlation. Generally in the direct method we are using this small r is equal to summation xy by summation x square into summation y square, but we should remember what is capital X, what is capital Y. Xi minus x bar equal to capital X and yi minus y bar equal to capital Y. We know that the standard deviations in that, after the simplification we are getting summation sigma x square summation sigma y square. Why? Because it we can take the whole square, and it we can take the whole square. Okay, this is the definitions of the correlation coefficients and the covariance.